All right, so now moving on to the next video, which is our last video before our next assessment, and that's going to be 3E. And now we're taking everything we're doing just one step further. So we've been progressing step by step in all of these videos, and now we're going to be solving equations with variables on both sides. So your learning objective for today is one, being able to solve equations with variables on both sides. And now we're going to also introduce what's called special case equations, where you'll have to know how to solve and interpret them. So sometimes, now that we have variables on both sides, sometimes there's going to be some unique cases that happen that you'll have to be able to identify, interpret, and give me the final solution. So this video is just going to be going over some questions, maybe 3 or 4 that we'll do, and that will be the video. So it should be a little bit shorter, hopefully. All right, so our first example we're going through is 5x minus 4 is equal to 3x plus 26. So we have variables on both sides. So one of the things before we do this I want to talk about, though, is when we had the question 5x is equal to 30, and when we're solving with variables and we have this coefficient up front that's being multiplied, we're used to dividing. But that's when we isolate our variable all by itself. So you see, we divide here because we're trying to get 1x, so that way we can solve for what 1x is equal to. So when we isolated everything and got our variable on one side and a constant on the other, yes, we are just dividing or multiplying in that case to get our variable to just be 1. But when we're trying to move things from one side to the other, then we want that to completely disappear and not exist on that side anymore. And if you can think about, well, what number that we know of can represent something disappearing mathematically, that will be 0. So we want to get it to 0. So when we're moving things from one side to the other, that's where we use subtraction or addition to do. So when we're moving to 0 out, we are using subtraction or addition. When we're trying to isolate our variable just to get to one of them, that's where we're going to be using our multiplying or dividing. So even though we might see these coefficients in front of our variable, we're not dividing or multiplying until we get to the very end. So my goal is to get my variables on one side and to be equal to my constant on the other. So that way I can isolate it and get it down to this one of my variable. So to do that, I need to move all my variables to one side. You're going to always see me move my variables to the left. So I want to move this to the left-hand side. Well, as we just talked about, in order to move something from one side to the other in its entirety, we can only use addition or subtraction. So then I'll ask myself, all right, this is a positive 3x. Positive is addition. So that means I need to get rid of it, and my inverse of adding is subtracting. So I'm going to subtract 3x because 3x minus 3x is equal to 0. So it is zeroing it out. And what I do to one side, I have to do to the other. So 5x minus 3x is 2x, and now I have minus 4 is equal to 26. And now this comes right back to what we've been doing, and that is our multi-step, there's two-step equations. And remember, we do this in reverse with PEMDAS. So I see I'm subtracting and multiplying. So that means I don't need to worry about any of these others. My inverse of subtraction is addition. My inverse of multiplying is dividing. So now I'm just going to go ahead and solve. So I'm going to get rid of my subtraction first since it starts at the bottom of my line. So I add 4 to both sides. So 2x is equal to 30. And now I got rid of my subtraction. The last thing I need to do is get rid of my multiply, which is dividing. So I divide each side by 2 since that's what's being multiplied, and x is equal to 15. And that will be our final answer. So in the beginning, we always are going to simplify everything as much as we can. And that is through multiplying, through combining like terms. And now simplifying is also going to be, let's move all of our variables to one side. And then we can start tackling the problem with something that we're used to seeing of just a regular two-step equation. All right, so our goal is when we're solving with variables on both sides is we need to move all of our variables to one side and all of our constants to the other. All right, let's go ahead and do one more question, and then we're going to get into the special cases. All right, so for this problem, they can appear in different ways. So remember, the first thing we want to do is we want to simplify everything that we can. So I see it's 3 times 2x minus 5. So I'm going to distribute this 3 in just like we learned in our last video. And 3 times 2 gives me 6. So 3 times 2x is 6x. And 3 times negative 5, well, that gives me negative 15. So it's 6x minus 15 is equal to 8x minus 65. And now, once I simplified everything that I can, I'm looking to combine my like terms. And there's no like terms for me to combine on either side. So now I'm looking to get my variables on one side and my constants on the other. I like to move my variables to the left-hand side. You can do it in other ways. So if I'm going to move this to the left-hand side, I see I have a positive 8x. So to move a positive 8x, I need to subtract. Well, this gives me 0 and 6x minus 8x. So 6 minus 8 is negative 2. So it gives me a negative 2x minus 15 is equal to negative 65. Now that I've isolated it down to here, I'm now going to solve it like we've done in a lot of other questions. So we're going to then look at our PEMDAS in reverse. Well, I see I'm subtracting and I'm dividing. So in order for me to get rid of subtraction, I know I'm going to have to add, and divide will be multiply. I'm sorry, that is not dividing. I was jumping the gun with it a little bit. It is multiplying. And in order for me to get rid of multiplying, we are going to have to divide. I don't need to worry about any of these other ones because they're not part of this problem. So I'm going to add 15 to both sides. So I need to get rid of that subtraction. So now I get negative 2x is equal to negative 50. And now from there, I have my multiplying I need to get rid of, which is division. And remember, we're multiplying by negative 2. So I need to divide by negative 2. I'm going to write the answer over here. So if we are then dividing, this is going to cancel out. So x is then equal to, well, negative divided by negative is positive, and 50 divided by 2 is 25. So our final answer is x is equal to 25. All right, so now we're going to get into special cases. And the first one we're going to start out with is going to be set up in a way that's going to be easier for us to solve so that we can kind of see what might happen and what will trigger a special case. And then the last one is going to be one that is kind of combining everything that we did in this unit into one question. So it's a little bit tougher for us to go through and a little bit more challenging. And then we'll go through it together in this video, and then we'll see another special case that happens from it though. All right, so let's go ahead and start with these special cases now. All right, so example 3, this special case, we're solving for x. And it says 8x plus 6 is equal to 8x minus 10. Something should hopefully maybe jump out at you already with the way that this equation's written and be like, whoa, this doesn't make sense. Like, how is this going to be possible? And hopefully that's jumping out at you already. But let's go ahead and talk about this. All right, so remember, the first thing we do is we simplify. Well, there's no multiplying. There's no combining like terms that we do. So there's nothing left there. I see I have variables on both sides, so I do need to set it up that my variables are equal to my constant. And in the other questions, you saw me circling the variable I was moving and drawing the arrow. So that way I'm reminding myself which one I'm moving. And it becomes a little bit more important in this problem where it turns into a special case. So I like to move my variables to the left. So I am going to move this 8x to the left. It is a positive 8x. So to get rid of that, I'm going to subtract. Well, when I subtract 8x from both sides, it completely eliminates my variable, period. They're both 0. So in this case, I have no variable left. So I have 6 is equal to negative 10. You will be able to identify that it is a special case when your variables eliminate. So if you no longer have a variable left over and it completely gets eliminated, well, then you know that something is up. I don't have a variable anymore. So when we're doing special cases, it's where we are trying to solve, and when we start to move our variables to one side, they completely eliminate. And then we get the statement, 6 is equal to negative 10. Well, we're asking ourselves, does that make sense? No, 6 does not equal negative 10. So when we're doing our special cases, we need to look at the next statement and say, is this a true statement or is it false? And this is a false statement. So now, when it is a false statement, what that tells us is that there is no solution. So this is your answer for this question. False is not the answer. False is what drives us to the answer. Since our variable is eliminated and we got a false statement, meaning 6 is not equal to negative 10, that means no matter what we substitute in for x, it will never work. And it should make sense at this. If we try to plug in a number for x, well, we're multiplying both of them by 8. So they would be equal after we multiply them both. However, this one we're adding 6 and this one we're subtracting 10. So if those numbers are equal after being multiplied by 8, well, when we add and subtract, they'll never be equal ever again because one is being increased while the other is being decreased. So no matter what, there is no number that we can substitute in for x that works. So our final answer for this is no solution. False is not the answer. False is what tells us what our answer is. All right, so if our variables eliminate, that's where we know, okay, something's up. This is a special case. And now we need to look at the statement that's provided. And we need to say, okay, is this a true or a false statement? When it's false, it means no solution. And next, we're going to go through what happens when it is a true statement. All right, so now there's one more example and we're done with this video. All right, so here's our last problem. This one's a little bit harder than what we've been doing because we have multiple cases of distribution. It's on both sides. So it's kind of taking everything that we've done so far and putting it into one problem. So remember, our first thing though is always looking to simplify. And that's through multiplying or combining our like terms. So I see we have these parentheses, so I know that I need to distribute and multiply. So I'm going to simplify that first. 5 times n is going to give me 5n. So now I have minus 5 plus 5n. And 5 times negative 7 is negative 35. Then I'm going to distribute this 5n. Well, 5 times n is also 5n. And 5 times negative 8 is minus 8. So I simplify by multiplying. Now I'm going to look, is there any like terms I can combine? Well, yes, on this side, I have two constants, so I'm going to combine those. So now I left with 5n. Well, negative 5 minus 35 is equal to negative 40. So I have 5n minus 40 is equal to 5n. Whoops, I'm sorry. I did this multiplying wrong. So 5 times negative 8 is negative 40. So now I have 5n minus 40. All right, so from here, something should jump out at you as well. Like, whoa, okay, wait a minute. 5n minus 40 is equal to 5n minus 40. Something should hopefully be triggering. Well, once we once we simplify, we're now looking to move our variables to one side of our equation. So I'm going to move my 5n to the left. Since it's positive, I'm going to subtract. And when I subtract, both of these cancel out again. So now I'm left with the statement of negative 40 is equal to negative 40. Well, same thing. Once our variables disappear, we're saying, okay, this is a special case. Now I need to look and see, well, what about the statement? Is it true or is it false? Well, negative 40 does equal negative 40. That is a true statement. So now what this is telling us is when it's a true statement, that means that all real numbers work. So you can write all real numbers, or if you wanted to write infinitely many, I would accept that as well. So when it's a true statement, it's telling us that no matter what number we plug in for x, it's going to work. And it should make sense. And once we get to here, in both cases, we're multiplying by 5. So no matter what number I plug in for x, they're both going to get multiplied by 5. So they're both going to still be equal. And then after that, they're both being subtracted by 40. So no matter what I plug in, they're still always going to remain equal because on both sides, we're multiplying by the same number. And then after we multiply, we will be subtracting by the same number. All right, so that is it for this video. This is the one thing I just want to do real quick before I end it. Is I'm just noticing now that every single time I only had positive variables. So let's just say that this was a question. And if I wanted to go ahead and solve this, since this is negative, if I want to move it to the left, I would be adding it to both sides. So that's just the only thing I wanted to point out too, since I just realized now that every single question we did, our variables were positive. So I just wanted to point out that if we're moving it to the other side and it's a negative number, that means subtraction. So we'll add it to get it to the other side. All right, so now that is it for this video.